Rock and roll. So today we're going to talk about, this is actually wrong. I forgot to change that. Sorry. Yeah, your learning target there is incorrect. I didn't change it when I did the edits. I always just bring up the last one and work through it. But we're going to use differential equations to model exponential change. It's great. Okay. And I find it interesting that 5 years out, this time 5 years ago, we weren't coming back to school, which is crazy to me. Uh-huh. Sheesh, right? I always get sad when my memories pop up because it was Becca's senior year and we were like it was the end of everything, so.
Every time I think back about it, I feel older.
You feel older? Well, you are.
5 years ago.
I know, it goes quickly. All right, so the CDC is responsible for controlling the spread of infectious diseases and providing assistance to other nations to improve their health. Programs around disease. They're keeping track of the current outbreak of the coronavirus disease. So I'm going to guess they wrote this in 21. They've revamped all the investigations for next year. I'm really excited. So I'm excited to see which ones they change and which ones they keep the same. But anyway, so let's take a second. There are, I think, 4 or 5 questions. All right. Work with your table groups. Let's work through these. Okay, it's going to walk you back through kind of what we just did in the warm-up. Okay, so take a second and work through that for me, please. Did y'all struggle to get up this morning? I did too.
I woke up in plenty of time and my car was broken.
Oh. Yeah, it's going to be cold tomorrow too, so heads up.
I should probably use the break as kind of like catch up on sleep. I ended up just like staying up all night and then sleeping till noon.
Yeah, we stayed up later than normal, and we didn't get up, but we got up like 7, which when you're used to getting up at 5, that's a huge difference. So, but anyway, yeah. I read a lot, took some naps.
I did not fix my sleep schedule tonight. I could not go to sleep, but I'm fine running on 5 hours of sleep. But if I get the like 7.5, I'm just short.
Yeah. It's crazy.
Yeah. And then
How was Universal?
it was so.
It did amazing.
Yeah.
It's so good.
The motorbike ride.
Yes.
It was so good.
I didn't get to ride it. Becca's not a ride person, so didn't I want to go back just to ride rides?
Yeah, it was good. We rode it the first time during the day, and then we went again, and we rode it at like 10 o'clock. It was so good.
Yeah.
Are there any specific
What I liked, Velocicoaster was so fun. We went in the back our second time, and it felt insane. I felt like it was going to touch. Yeah.
Really?
Yes.
Okay.
I'm
How
not
fast
gonna
does it
see
go?
it.
I don't know.
About 100,000 miles.
No.
Yeah. Well, I watched I don't know, a reel or something where it talks about the speeds of all the coasters at Disney, and that Cosmic Rewind is the fastest like 74 miles an hour. It just made me want. I'm thinking, oh, it was my favorite, you know. But
Cosmic Rewind doesn't feel as fast.
it doesn't feel that fast though.
I guess Tron.
I didn't ride Tron because at that point I didn't know they had one where you could sit in the car. But
Yeah.
I was like, there's no way
Yeah,
I
there's
can
one
run
in the
over and
back.
ride that. Yeah, but there is one where you can sit. I didn't know that, so I didn't get into line. I didn't get a fast pass at that point. You had fast pass to ride it. So.
Oh, you still do.
Yeah, I know. I'll do that.
Yeah. Just a little rusty.
Oh, wait, we don't need an X. Just need
You're right there. Wait, where else? Great.
The first, number two. Okay. What's for your, you get one.
Yeah. We're using DYDX. If you want to separate equals KY.
Yeah, there has to be a constant proportion or something. So that's just like
Yeah.
Oh, I used to. Is this? Yes. I used to.
Yeah, so.
I don't know any of that. That's the.
I forgot the list.
Granted, we did kick it last. Yeah.
Oh, we
One
can
thousand.
look in. Oh, right, well, we did that.
Oh, Laura, don't forget you've got that quiz to make up.
Yes, can I come in for what?
Yes.
K goes to 0.
Yeah.
The negative solution here doesn't.
I'm on Mars, I don't know what it's called, but I'll reach it.
Oh.
I've given up on
Don't worry.
Well, see, but now we know the difference, right? We know the number of people there.
Yeah.
Bless you. This is what I've missed. It's like, I miss that. Just the normal banter.
Yeah.
This is probably
Y'all just messing with it, huh?
I mean, you got numbers.
Yeah, the numbers.
Better than if you got letters.
Exactly.
Some of them are letters.
That's true.
Calculator.
That sounds good.
Oh, if you want a numeric search.
Flip.
'Cause-
He almost got all the way to the shoes for St. Patrick's Day today. I appreciate it. Yes.
You not know this?
I always wear green, bro.
That's
I don't think that's just true.
Most of the time.
Half the time.
Half the time.
Or you're just a Slytherin. Are you Slytherin?
Slytherin.
No, I took the test on phone.
We both got Gryffindor.
No. you
I'm
know my
Hufflepuff.
house.
I didn't steal your house. There's no
You were
Imagine not
Ravenclaw.
being a Ravenclaw.
No, I was Gryffindor.
Rebecca's a Ravenclaw.
I was smiling at my brains.
Russell's old, bro.
It was my phone. I didn't steal anything.
Russell's back.
I just grabbed it back and I took a photo showing my
Okay, so then we
house,
do E,
my
E,
pride and joy.
Uh-huh.
exponential.
You see voice X. Yeah,
E to the power.
So we got flag football Saturday.
Really?
Yep.
Still all that comes out.
Yeah, I'm excited.
It's not in the LN. The X is in the LN.
I wonder who we play.
Westmoreland and Beach, I think.
Probably.
Play at 11 and at 12.
Oh, alright.
So back to back.
Let's see how that goes.
But then what the seven's not gonna win.
But the 7 is in this.
Exactly.
All right, let's see how we're doing. So it tells me in the first part that the number of people P that are infected by the coronavirus is increasing at a rate proportional to the number currently infected. So it wants me to write a differential equation. What would that differential equation be? All right, so dp dt, so at a rate, so that's where we get the dp dt. KP, directly proportional to the people who are infected, okay? So it doesn't say directly, it just says proportional, so we can assume it's directly proportional, okay? Then it goes on to tell me that when the epidemic is first discovered at time 0, 1,000 people were already infected. So it walks me through the steps. It says to separate and integrate. So we would get what dp, thank you, over P would equal K dt. And they want us to go ahead and integrate. What's that going to look like? Absolute value of P. KT plus a constant. Okay, so K is just that constant. We're integrating with respect to dt, so it would give me a T to end up with just a constant, and then plus C. Okay, all right, so then it tells me to solve for C. So we want to use that initial condition at time 0. The population is 1,000. So I have the natural log of the absolute value of 1,000 equals K times 0 plus C, or C is the natural log of 1,000. Okay. And then finally, it says to isolate P and select the proper solution. So we have the natural log of the absolute value of P is going to equal KT plus the natural log of 1,000. I'm just going to put that in a parenthesis so I realize it's a whole term. Okay. Now, when we solve for P, all right, we would use an E to the KT plus the natural log of 1,000. Now, before we left, we talked about when we have an ln in an exponent and it's being added, that's really like exponent properties. We had an e to the kt times an e to the ln of 1,000. What would happen to that ln of 1,000? It would reduce out and just be 1,000 up in front. So I get the absolute value of P is 1,000 e to the kt. And then when we solve absolute value, we actually get how many solutions? 2. All right, gives me plus or minus 1,000 e to the kt. Well, there's only one solution to this equation. It's based on our initial condition. Our initial condition says it has to be a positive 1,000. So which one of my solutions am I taking? The positive one. So P is going to equal 1,000 e to the kt. Okay, so that's what we had learned all before we left. Okay, what we had learned. All right. Now, the beautiful thing about this process we just walked through, anytime we start with that differential equation, dp dt equals k directly proportional, that is exponential change. Okay, and every time, okay, that we solve that differential equation, we're going to get P equals P sub 0, my initial condition, e to the kt. All right, every time, okay? Now, is it necessary you memorize that? No, but that should look like something you should remember from Algebra 2 and Pre-Cal. We used it a lot with money applications. Remember when we did PERT? P, we did interest, continuously compounded interest. P sub 0, that's our initial amount we put in. E to the KT. K, we replaced it with R. It was our rate of growth or rate of decay. So it's the same thing, you just didn't know it came from a differential equation. All right, but that's where it came from. All right, that's the law of exponential change. All right. Now, let's flip over to the next part because it asked me to solve for K. All right, so we've got this equation now, P equals 1,000 e to the KT. All right, at time 0, 1,000 was my initial condition. All right, so if we switch over and we look at the next thing, it tells me that on the 7th day, 1,200 people were infected. So that's giving me the ordered pair 7, 1,200, right? And I have the equation P equals 1,000 e to the KT. So what we can do is replace those two variables based on what we were given. So 1,200 is going to equal 1,000 e to the 7k. All right, and then we're going to solve this equation. It's been a hot minute since you've had to do anything like that. Okay, how do we solve that exponential equation? Divide by 1,000. So we get 1.2 equals e to the 7k. All right. We use an ln, so I get the ln of 1.2 equals 7k. I'm going to put parentheses around that. And so k is actually equal to the ln of 1.2 all divided by 7. That's an exact number, okay? If we used our calculator, it would give me approximately 0.026 for k, okay? So basically now we know the actual equation, which is P equals 1,000 e to the 0.026 t. Okay, so that's my exact equation for this situation now. All right, but we had to find that rate of change, that rate constant up there, that K. Okay. So then it says how many people are infected 12 days after the epidemic's first discovered. What should we do? Plug in 12 for T. Good. So P is going to equal 1,000 e to the 0.026 times 12. You could leave that exact. All right, ln of 1.2 over 7 times 12. I mean, you could do all that. But we should end up with about 1366.908 people. Might be off by a little bit. And then finally, after how many days would 3,000 people be infected? Where does the 3,000 go for P? So we get 3,000 equals 1,000 e to the 0.026 t. And let's talk about solving that bad boy. Okay, what would you do first? Divide by 1,000. So I get 3 equals e to the 0.026 t. And then what would we use? ln of 3 is going to equal 0.026 t, or t is going to equal ln of 3, the whole thing divided by 0.026, which will give us about 42.180 days. Okay, so just walking us back through several different ways to solve. Okay. Now, how is this going to affect what we do? All right, how does it affect what we do? Well, it's interesting how they ask the questions sometimes in reference to exponential change. Okay, any questions about all of that? We're just plugging in values they gave us that we could solve for the things we needed, and then it's really just algebra after that. But anytime it's the law of exponential change, this is the situation. The rate of change of y is directly proportional to x. Okay, so it's always that direct variation. Okay, so what we just solved, dy dx equals kx, and if we worked it all the way out, solving that differential equation, y would equal plus or minus c e to the kt, or kx, I'll put x there. Okay, so it's always that. Okay. Now, question, how do we know when it's growth or when it's decay? When it looks like this, anybody remember? It has to deal with decay if it's positive or negative, right? So if k is greater than 0, then it's growth. If k is less than 0, it's decay. Okay, so that's really the different thing. It's our law of exponential change. So let's look at this first example where they're going to give me some information and they're going to ask me to pick, all right, which one I think is the most appropriate model. This is where we just have to recognize that they've given me exponential change, okay? So let's look at this one. It says a kitten weighs 85 grams at birth. Oh, Mr. Jablecki got a kitten over spring break, and she's so pretty. She's white and gray ears. Jablecki did. She's sweet. Her name's Margarita Clementine.
Margarita Clementine.
I mean, that's a mouthful of a name, but that's her name.
Why did you do that?
I don't know.
That's gonna be a big fun of it.
Well, in preschool, I don't know, but I feel like we're going to need a nickname. Rita. Clemmy. Like, there could be lots of really good. There could be lots of good ones. So a kitten weighed 85 grams at birth. During the first 4 weeks after birth, its weight in grams is given by this function W, which satisfies the differential equation. This is the first thing that I should recognize, is they have given me exponential change. Okay? That differential equation is exponential change, where T is in days and K is some positive constant. Okay? That's important. K is a positive constant. That means, do I have growth or decay? Growth. And it makes sense that our kitten should increase its weight, all right, not decrease. That would be bad. All right, which of the following could be an expression for W of T? So what we have to look for, are there equations here that don't model exponential growth? Yeah, B and C. I didn't mean to use the highlighter. B and C for sure we can mark off. Like those are, or B and D, sorry, aren't even options because they're not exponential growth. Okay, and then here, as we're recognizing what's left, all right, which one uses that initial condition of 85? C. All right. So there will be some that'll be that simple. All right, where you're just choosing the correct model, which is nice. All right, without really having to do any math. So that's always a good day. Okay. All right, let's see what's next. All right, so here's one they want me to actually work out. All right, so not... All right, not multiple choice to start, one that we're going to actually do, okay? And this one really, okay, it's just, let's just work it out. All right, let's just work it out. All right, so it says y is 1 when x is 0. Start to look at, as you do the whole thing, all right, using the properties and all that good stuff, do you find some things that are helpful? All right, in the process in terms of helping you figure out what to do. Okay, but let's just walk through it all. So it gives me dy dx is equal to 2y. It's a differential equation. We're going to separate variables. dy over 2y equals dx. And then we're going to integrate. Okay, now Be careful right here. Okay. Could I have left the 2 on the other side? And just move the y? I could have, okay? And if I'd done that, it might have been a little bit easier for me to do this, but we got to think here. This is ln, but it's not just a y, all right? There's a 2y sitting there, okay? And so if I were to take that makes it a chain rule, all right? So if I were to take the derivative of that 2y, what would I need to do? Yeah, I'd have to balance that. I'll have to put it in, right? So I'd have to put the 2 here and a 1/2 on the outside, okay? Now, most of us don't like to do that, okay? So here's what I'm going to do. I'm going to scrap it, and I'm going to leave the 2 so that I don't have to do that, okay? So if you don't like doing that, leave the constant on the other side, okay? So this gives me dy over y equals 2 dx. That's going to be a lot easier to integrate. Okay, not that the other was hard, it just required more thought. Okay, and there's just an easy mistake you can make there. All right, so ln absolute value of y is going to equal 2x plus a constant. All right, a lot easier integration. All right, use your initial condition. All right, y is 1 when x is 0. Okay. So let's do that. So let's plug that in when x is 0. So I get ln of the absolute value of 1 equals 2 times 0 plus c. Well, what's the ln of 1? 0 equals 0 plus c. So c is just 0. Okay. So I have the natural log of the absolute value of y equals 2x. And now we are going to solve for y. So absolute value of y equals e to the 2x. Or y equals plus or minus e to the 2x. Which one are we going to take? We're going to take the positive because we want it to be positive 1. So e to the 2x based on that initial condition. Okay. All right, rock and roll. So let me ask you a question. What's k in this problem? K is the 2, right? It was that constant that was left there next to the y. Okay, k was 2. We didn't need it for this process, but that's what it is. They didn't ask me to solve for k. They gave it to me, okay? So now we want to find the value of x when y is 3. So we're just going to plug in 3 for y equals e to the 2x. And so then how would you solve? ln natural log of 3 is going to equal 2x. Or x is going to equal the natural log of 3 divided by 2. I don't have the decimal approximation in front of me. Okay. All right, y'all try the next one. It's multiple choice. All right, what do we think? Well, what do we think it isn't? Yeah, it's for sure not E, okay? We can look at it and see that that's got to be an exponential growth just because of how it's set up, okay? So we can for sure mark off E because we're not going to get that 2x squared, all right? If you do your separation, dy over y equals 4dx, we should realize really quickly that we're going to get that exponential growth model, okay? And so now it makes sense that every exponent up there has a 4x in it, right? Because when I use E, they're going to all be to the 4x, right? If we put in our initial condition, okay, when x is 0, y is 4, we get C is equal to the natural log of 4, okay? So my equation becomes natural log absolute value of y equals 4x plus the natural log of 4. And now when I use E, all right, we exponentiate both sides. I'm going to get absolute value of y. This e to the ln of 4 is going to give me 4 and bring it out to the front, okay? And then it has to be positive because I had a positive initial condition. You can learn, all right, to recognize these things. If you look at what we did just a few minutes ago and the one above it, okay, we realize that this number next to y is my k, so it will always be my exponent, okay, that's on E. And then this is my initial condition, and your initial condition is always in the front. So it had to be A just based on the equation. It's based on the data we were given, okay? But does working it out still provide the answer you're looking for? Sure, okay? It'll always work if you work it out. But that's just a time-saving kind of hack, okay? If you get used to it and you see it, all right? Looking for that y equals CE to the KT. All right, so K was 4 and my initial condition was 4. So that's why it had to be that. All right, let's look at one that is calculator based. All right, calculator based, and it is multiple choice. All right, these primarily are on multiple choice. Okay, you might have one or two, you might have one every few years that'll show up in a free response. It'll probably be this year. But, typically they're in multiple choice. All right. So this one gets really specific, and notice it's giving me decimal answers. All right, so it's expecting me to use a calculator. It says extreme heat applied to a colony of microorganism causes the size P of the colony measured in grams to decrease according to the exponential decay model, and it gives me an equation. Y'all, if they give me an equation, it's important. Okay. Where T is measured in hours. The size Q of a second colony, all right, decreases at the constant rate of 1 gram per hour according to the linear model. I think that's important. dq dt equals -1. Okay, if at time 0, the first colony has a size of 2, and the second colony, I didn't use that color, has a size of 2, and the second has a size of 3, at what time will they have the same size? Okay, so basically what we've got to figure out is what are these two equations we're messing with and when are they equal? All right, so that's what we're looking for. Now, if we look at the first one, all right, the pink one, they tell me it's exponential decay, all right? So I should be able to jump straight to an equation because is there a coefficient next to P? And so what does that represent? K. All right, so y is going to equal, we know it's going to be e to the -0.4 t, all right? Then my initial condition, bless you, is going to go in the front, okay? So what's its coefficient in the front? 2, okay? It's 2. Now, let's think about this Q equation, all right? It says dq dt equals -1, all right? If it tells me it's linear, in other words, I don't have to separate the variables, I just have to integrate, okay? So this equation would give me a -1 t plus a constant, okay? You can't forget the constant because that's my initial condition. What's my initial condition? 3. Yep, so -1 t plus 3. So it's like mx plus b if it's linear. Okay, they just gave you the slope, and then they gave you the initial condition, mx plus b. Okay, so now we use our calculator. We put 1 in y1 and 1 in y2, and we find where are they equal. Okay, you remember how to do that? Second trace, intersect, inner, inner, inner. Okay, what does it give me? Yeah, it should give you C, 2.156. Okay, so looking for that intersection. So they are able to test a lot of things right here. They're testing your calculator skill. They're testing your understanding of a linear differential equation and an exponential differential equation. All right, so they like questions like that. All right, they can assess multiple skills with one question. We're so close. Do we need a chain countdown?
Yes.
Like we tear off a chain every day? Okay, I'll work on that. Because I got to have 2, because second block's got to be 1 day longer than y'all's. Because theirs is the next day.
Oh, well, they're juniors?
Mm-hmm. No, to their AP test.
Oh.
Because once you hit your AP test, school's over. Yeah.
When do you have?
Monday the 12th. And theirs is Tuesday the 13th. I mean, I can't be, I mean, I'm just there to give y'all the rah-rah as you go in, that's all. Okay. All right, let's look at the next one. Ooh, this one's a little more complicated. Okay, a little more complicated. Look at all this chemistry, all you chemistry people. During a chemical reaction, the rate of change of the amount of the chemical remaining is proportional to the amount remaining. At T equals 0, the amount of the chemical is 12 moles. At T equals 4, the amount of the chemical is 4 moles. At what time T is the amount of the chemical 3 moles? A mole is a unit of measure used in chemistry. Thanks for sharing. Okay? All right. I would think that if you got to AP Cal, you knew a mole was a unit of measure. Okay, but maybe. All right, moving on. So let's work through everything they've told me, because what I'm looking at over here are exact answers. This is a non-calculator question, and it looks terrible. Okay, so let's work through what they told me. Okay, the rate of change of the amount of the chemical remaining is proportional to the amount remaining. Okay, so dy dt is proportional to what we've got left, ky. All right, it is exponential change. All right, now, did they tell me K this time? No. Okay, they didn't tell me what K was because they didn't give me the differential equation. But they did tell me that at time 0, the amount of the chemical is 12 moles. Okay, so I could write an equation. We know my initial condition is 12, so that's my C, e to the kt. So they told me that. Okay, you could do the differential equation if you wanted to, solve it all out, but that's where you should land. Okay, so 12e to the kt. The next thing they tell me is important because it says at T equals 4, there are 4 moles. How could I use that to figure out K? I need to know K. So they gave me, there are 3 variables in that equation we just wrote in pink. You see them? Okay, but they gave me the X and the T, the Y and the T, so I could find K. All right, so let's do that. Let's find K. So that's going to give me 4 equals 12e to the 4k. And we're going to solve. All right, so this is where it's going to get fun. All right. All right. Now, 4 over 12, we would divide, right? What would that give me? 1/3 equals e to the 4k. And then what are we going to use? ln. So natural log of 1/3 equals 4k. And so k is going to equal the natural log of 1/3 all divided by 4. Okay, y'all, that looks terrible. All right, but it is what it is. That is k. All right. So then it asks me to go one step farther, and it says, at what time is the amount of the chemical 3 moles? So I got to solve this equation. Now, look at this when we start. Okay, so y is going to equal 12e to the ln of 1/3 all divided by 4 times t. Okay, but, all right. So we're going to do some algebra next, because if I look at my answers, none of them look like that. Okay? So we want to know when it's 3 moles. So we're going to put 3 right here. Equals 12e to the ln of 1/3 all over 4 and a t. Okay. I'm feeling lucky. Not really. Okay, here we go. Let's start to solve. All right. What would I do first? Divide by 12. So it's going to give me 1/4 equals e to the ln of 1/3 all divided by 4 and a t. Okay. What are we going to do next? ln. Okay, so I'm going to get the ln of 1/4 is going to equal the ln of 1/3 all divided by 4 and a t. Everybody with me so far? Okay. Now, we need to solve for t. So basically, I'm going to multiply by a reciprocal. Okay. Now, none of my answers look like what I just had right there for t. Okay. So what that means is we got a lot of algebra happening in this problem. All right, in terms of simplification. So I'm going to ask you to go all the way back to logarithm rules. Okay, and logarithm properties. When we divide within a logarithm, how can we separate it? Subtraction. Okay. So t is going to equal 4 times the natural log of 1 minus the natural log of 4 divided by, all right, 1 times the natural log of 1 minus the natural log of 3. Okay, does everybody see what I did right there? I just used prop. I love you, Oakley. She went, no, not even close. All right. Logarithm rules. When you divide within a logarithm, you can split it up as subtraction with that 1 log. Okay, so like if I have ln of x over y, it's the same thing as ln of x minus ln of y. If we had ln of x times y, that's ln of x plus ln of y. So properties of logarithms. So I just expanded it. And there's a reason why I wanted to expand it. Okay? What's the ln of 1? 0. Okay? The ln of 1 is 0. All right? So this is going to give me negative 4 natural log of 4 over negative natural log of 3. What's going to happen to the negatives? They cancel out. And so I get 4 natural log of 4 over natural log of 3, which is d. Okay? The calculus in that problem, really not that bad. The algebra, terrible. Okay? Because it requires you to recall all that stuff so that you can get to that simplified answer. Right? And that's the only caveat to multiple choice, is that sometimes they will simplify it. You will get all the calculus right, and then you'll be like, my answer does not match these. If that happens, probably you need to do some algebra to simplify. Okay, just as a heads up. Now, if this were free response, they would have taken that crazy complicated t is 4 times the ln of 1/4 they would take that answer, okay? But in a multiple choice, you got to select the answer in the form they provide, okay? So that's the tricky part to that one. All right, digest that for a second. We got 2 more to do and I'm done for the day. Whew, welcome back. Smack you over the head with some calculus. Okay.
Calculus is the easy part.
I agree. It's the algebra. I say that all the time. That calculus is the easy part. The algebra is brutal. Yes. Can I tell you what helped me the most? And don't just, this is, okay. So I took a year off. We know this, right? I had a year off in the middle of my college experience. And so when I went back, I needed, in order to graduate at Ball State, I needed 1 more math credit, and I didn't have space in my schedule for differential equations. And so I was going to wait and take that when I got to Tech. And so in order to be able to graduate, I had to have another math credit. So I convinced them to let me take college algebra. All right? Just, they're like, yeah. I'm like, come on, I just need a credit. I mean, I've already passed all this other. Can I just take it? And so they did. They let me take it so that I could graduate on time. Y'all, it was the best thing I did because all of this crazy algebra that you don't use all the time, when I got to Tech and did Diff-E and all that other calculus, I was so grateful that I had done it because it helped so much to remember all my algebra skills. Anyway, so what they thought was useless was really helpful. Okay, anyway, here we go. Ooh, ooh, welcome back. Okay, so write the equation of the tangent line to y equals w of t at t equals 0. Given that w at 0 equals -7 and dw dt equals 2tw plus w. And then use the tangent line to approximate w at 1. Now, I gave you this one on purpose. Is this exponential growth? No. Okay, it's not directly proportional. They've thrown something in here that's just totally separate from what we've been doing, but we're still going to use a lot of the same principles. How do we write an equation of a tangent line? We need a point and a slope. Okay, now the good news for me is they gave me that point. What's my point? 0, -7. Okay, and they gave me a formula for my slope. So let's use it. Okay, they gave me the formula for my slope. So we're going to evaluate it when t is 0 and w is -7. All right, so dw dt is going to equal 2 times 0 times -7 plus -7. So what's my slope? -7. Okay. My tangent line, that's the next part. That equation always has to start with what? Y equals, thank you very much. We're going to take our slope, -7, t minus 0. You could just put t if you wanted to, and then -7. Okay. And now we use the tangent to approximate w at 1. Equal -7 times 1 minus 0 minus 7. -7 minus 7, or -14. So in the middle of all the craziness we've been doing, they're going to throw you something like that. Okay? Just write me an equation of a tangent line. All right? All right, y'all do this last one. We're going to be done. Bless you. And I don't know why there's an L right here. Okay. I was typing L.
So many spaces.
Yeah, I know.
Falling asleep on the keyboard.
I guess so, it happens. Sometimes you have to plan when you get a minute, and sometimes it's late. I'm better now than I used to be, though. All right, so let's look at this one. So the rate in degrees Celsius per minute at which a hot pot of water cools is given by this differential equation, where W is the temperature in degrees Celsius and T is time in minutes. The pot of water is 81 degrees Celsius at time 0. Use the tangent line to estimate W at 2, okay? Now, the main reason I show you these is so that we get out of this habit, or that we get into the habit, let's say, that we get into the habit of reading the entire question before we just start working at random, okay? Because once you start to see a differential equation, you're gonna wanna start to integrate and separate and do all the things, right? Because we think that's what we're supposed to do, but we don't have to in this one, right? I'm writing a tangent line, so I need a slope and I need a point, all right? So my slope is dW dt. It's gonna equal negative 1/3. Okay, the temperature of my water was 81 degrees plus 21. Doing math. Is it negative 27? Plus 21 would give me negative 6. Okay, so 3 goes into 81, negative 27. Yeah, all right. So there's my slope. My point that they gave me, all right, was at T0, 81. And so if we write the tangent equation, y is going to equal negative 6, all right, T minus 0 plus 81, and then we fill in 2. So W at 2 would equal negative 6 times 2 minus 0 plus 81, or negative 12 plus 81, which would be 8759. $69 degrees Celsius. Okay, so there we go. All right, your lesson practice. Okay, lesson practice. There are 3 problems out of your book on page 373, 374, 41, 42, and 43. And then there's a worksheet back there, 7.8. It has lots of good different types of differential equation problems. All right, there is a wrap up, so let's get that done.